Welcome to the lecture. In this lecture series, we are discussing about the neural networks starting from biological neurons and artificial neural networks, and we have discussed about the single layer perceptron, and now we are going to discuss about the limitations of perceptrons. So first of all, we have to know this what is perceptron is. It is the simplest form of artificial neural network. So this is the structure you can see. It consists of an input, weightage layer, weightage sum, activation function, and our output. And it's mainly used for the binary linear classification, and it is found in the modern deep learning also. So first algorithm was developed with the probably convergence theorem, and architecture is it has input, hidden layer, and final output. Input layers is x1, x2 until the xm, and we have the synaptic connections like w1, w2, and up to wn. We have the summation point where the weightage and the input is multiplied and given into sum plus bias condition. Activation function is step function which holds the threshold value, and output will be, since it is a binary linear classification, the output will be also binary, either 0 and 1. And next, coming to the prediction error. So we know in the step function, if the output will be 1 if the summation is greater than 0, or the output will be 0, right? So here we have to go for the prediction error, that is actual outcome is 0 and predicted outcome is 1. So error is -1, right? So compare the prediction against the actual outcome by subtracting the two numbers, we can find the prediction error. So now I have to correct this error. So what will I do? I go for the adjustment of the weightage. And next, coming to that, we have to know the user perspective. How do practitioners experience perceptron limitations and identify the real-time scenarios? And we have to understand the challenges, and main point is not used for the nonlinear problems, and it is complex for the pattern recognition. Coming to the stage 2, yes, we have to identify the problem, we have to identify the limitations, user need, and design criteria. Coming to the multi-layer architecture, adding hidden layers for the complex patterns, and it is nonlinear activation. Backpropagation techniques is also used for the algorithm adjustment, and it has a feature engineering. And we can discuss the limitation like the single layer perceptron is limited for the linear separable, that is linear classification, and here it uses only one layer of linear separation, that is single hyperplane only, and cannot solve the complex patterns. You can see the line may be vertical, horizontal, or corner, but with the use of this single line, I cannot clearly classify the green and red, right? Either the red is alone separated, or green will be combined with the red. So I have to go for the multiple layer, but with the single layer, I cannot use the two hyperlines. And coming to the next problem is XOR problem, and it is most probably used for and or, but it is not applicable for the XOR, since you can see circle and star, yes, applicable. Circle or star, yes, it is applicable. But in the XOR, the both circle and star comes in a straight line. We have to use double line. So double hyperplane is used. So single hyperplane cannot justify the classification. So next is convergence issue. It requires many iterations for convergence, as I have to decide which say direction of single line hyperplane is to be used, and no convergence guarantee, sensitive to parameter selection, and may get stuck in the sub-optimal solution. So in the next coming for the next architecture, multi-layer, you can see we have the many hidden layers. So 1 2, so we have n number of hidden layers. So what we can do is we can go for the next level of filtrage, and we can get the accurate output. So here you can see input, weightage, and directly it goes for the summation point, gives the activation function, whereas it is only acts in the single layer. From the single layer, again it goes for the summation and activation function, again it is filter. So in the multi-layer, we can guarantee for the convergence, and we can guarantee for the proper classifications. So in the next lecture series, we will discuss about the linear model basis and Bayesian model basis, etc. Thank you.